All right, class, we have arrived at special triangles. So these are triangles that have very specific degrees, and therefore they have very special properties that come along with them. The first one we're going to be looking at is the 45, 45, 90 special right triangle. And what this implies is this means that I have two of the angles are going to be 45 degrees, and therefore I have a right triangle. All of these summing up to 180 degrees. So every triangle has 180 degrees in the interior. So plus 90 equals 180 degrees. So why is this triangle special? Well, for one, the legs of a 45, 45, 90 triangles are always congruent. This means that this leg and this leg are the same exact size. And so this length here is going to be x, and so therefore this length is going to be x. So now we've done Pythagorean theorem, so let's come over here. And so what would the hypotenuse be? Well, I would have x squared plus x squared, and that would equal c squared. Well, this is just 2x squared, and that equals c squared. So let's go ahead and take the square root of both sides. All right, and so then I would have that c is equal to, remember for square roots, this is the same thing as saying the square root of 2 times the square root of x squared. So I get x here, and then I'm just left with the root 2 equals c. And so we often see it as x times the square root of 2 is our c length. Okay, and so that's exactly what we end up. So this becomes x times that square root of 2. So when we are looking at, and again, this is specifically for 45, 45, 90 degree triangles, our legs are going to have length x, but then our hypotenuse is going to have the length of x times the square root of 2. All right, let's put this into practice. So let's look at this first example. Right, we want to find the value of each variable. So if this is x, right, and notice this triangle. So this is going to be a leg, and this is going to be a leg. So these are congruent, which means that my x value is going to be 8. Okay, now this implies that this is going to be the hypotenuse, right? So if that's the hypotenuse, then I already know, because this is a special triangle, that I'm going to have 8 times root 2 is going to be the value of y. Okay, all right, go ahead and try 2 and 3. As we look at 2 and 3, hopefully it came somewhat simply. So our legs here, right? Notice that this time the y is the leg, so y should be 25, but then the x is the hypotenuse, so we get 25 times the root 2. Now this one was a little bit tricky because my legs are both the variables I was trying to identify. So notice though that if I take a leg and identify it as x, that means that the hypotenuse is really x times the square root of 2. So I have x times the square root of 2 is equal to 19. So then we're going to divide both sides by the square root of 2. So we get 19 root 2 over 2 once we rationalize it. And that would have been our hypotenuse, or our legs there. Okay. All right, let's take a look at another special triangle. And this is the 30, 60, 90 triangle. And so here, very similar to the last example, this is when the angles are fixed. So I have an angle of 30 degrees here. I have an angle of 60 degrees here. Right, and so let's take a look at this. So one thing with the 30, 60, 90 triangles is the shorter leg is always the opposite of the 30-degree angle, and the longer leg is always the opposite of the 60-degree angle. Okay, and so what happens here is we see that the 30-degree angle, here's our shorter leg. We are going to call this x. This is going to be our x value here. And then it so happens that in this case, our hypotenuse is going to be 2x, and then our other leg is going to be x times root 3. Okay, so our shorter leg is always going to be the x value. Our longer leg is always going to be x times the root 3 value. And then our hypotenuse is going to be 2 times x. Okay. All right, so let's go ahead and try some of these examples here using this special triangle. So if I know my shorter leg is 5 in this example, that means that the x value is going to be 5 times root 3. And my y value is going to be 2 times 5. So that's going to give me a 10. Okay. All right, and so let's take a look at another one here. Let's see. let's go ahead and do this last one just because it looks a little pixelated over here. So if I have the x value here, this is going to be my x value is my shorter value, but then I could see that my larger value is going to be 9 root 3. So then what does that imply? So this tells me that if this is 9 root 3, then my x value must be 9, because 9 root 3 is going to be equal to x times that root 3. So therefore, that x value must be 9. And so that tells me that the hypotenuse is just going to be 2 times the x value, which is going to give me 18. Okay. All right, try 5, 6, 7, 8 on your own. All right, so I'm hoping you're finding this a little bit straightforward here. So we have 28 for x, and y is equal to 14 root 3. And this was easily done because our shorter length was already given to us as 14. For number 6, we got 16 and 16 root 3. For 7, 23 root 3 and 23. Now number 8 was probably a little bit more complicated, only because that long length was 20. So we do have to set that equal to y, which is our shorter length, times root 3. So we're dividing by root 3. So we get that the y value is 20 divided by root 3. And once it's rationalized, we get 20 times root 3 over 3. So our x value was twice that. So then that's how we got that 40 root 3 over 3. And then number 9, we had already completed that one. All right, here we're going to be doing a little bit of mixed practice. So we want to find the values of each variable. So let's look at this first one. This first one, we are looking at a 45. So I have a 45-degree angle here, which tells me that this is also a 45-degree angle. So we have 45, 45, 90. This tells me that the two legs are congruent. And so this, all I have to do here is note that my hypotenuse is going to be 28, which is going to equal our x value times the square root of 2. So we're going to go ahead and divide both sides by the square root of 2. So I get 28 over the square root of 2 is equal to my x value. I'm going to rationalize this, so I get 28 over 2 times the square root of 2. And I can reduce 28 and 2 so that I have 14 root 2. So this is going to tell me that my x value is going to be 14 root 2. My y value is also going to be 14 root 2. Okay. All right. Let's go ahead and try some of these. Go ahead and see if you can do 11 through 18. All right, so hopefully you were able to get some of these similar answers. Number 11, 8 root 3 for the x value, because noticing that this is a 30 degree 60 right triangle, y value is 8. For number 12, we are looking at a 45 degree triangle, so our x value is going to be the same as that 4, and then we got 4 root 2. I think 13 through 15 were pretty manageable. I did want to talk about 16, just because we have the two, if you will, easier sides to calculate are the ones that need to be calculated, but I do have 6 as the long side. So I have 6 equals y times root 3. I do have to divide by that root 3, so make sure that we're simplifying once we rationalize. And so if your answer looks a little bit differently just because you didn't simplify, that could be the case. So go ahead and try to simplify that. So we end up with 2 root 3 for y, and then we just double it for that x value. Now for number 17, it did require us to remember a little bit of our algebra. So we have the square root of 10, right, is going to be equal to root 2 of x, because this is our hypotenuse. So when I divide by root 2 over 2, I do have the property that tells me that the square root of a over the square root of b is the same as the square root of a over b. And so that allows me to reduce inside, so I just get that the square root of 5. And both of these are going to be congruent since I have a 45, 45, 90 on this one. Okay. And then lastly, number 18 is just, we have 19 and then 19 root 3 here. All right. So hopefully that was pretty straightforward. Let's look at the last couple ones here. For number 19, let's take a look. We're looking for x, y, and z. So we do realize that this bottom triangle is a 45 degree triangle, but I don't have any of the given sides. So I really need to work with the top triangle first, which is given to me as a 30, 60, 90 triangle. So if I'm going to start off with the z value, so if I have 9 on the shorter end, right, then this tells me that the z value will be my 9 times root 3. Sorry, that's not right. Because z is my hypotenuse. So z is just going to be 2 times the 9 value. So we're going to get 18. Oops. 18 for z. So this tells me that this is 18. Okay, so now I can find this length here. So this length here is going to be given to me by 9 root 3. So now I have a side, right, which is now the hypotenuse of a 45 degree triangle. And so this tells me that 9 root 3 is going to be equivalent to x times root 2. So we're going to divide by root 2, so we end up with 9 root 3 over root 2. Let's go ahead and rationalize that. So we get 9 over 2, and so I get root 3 times root 2, which is the same thing as saying root 6. Okay. And so here we're left with the answer of our x value is going to be 9 root 6 over 2, and that's actually going to be the same as our y value. Okay, so those are our two values. All right, let's try another one of these. Let's try 24. We're looking at x, y, and the z value. So looking here, I have a 30, 60, 90 triangle, right? I have a 18 and a z here, and then I only have a 45 degree triangle here with no other information. So I need to start with the bottom triangle. So if my shorter leg is z, but my larger leg is 18, this is telling me that I'm going to have z is equal to, z times root 3 is equal to 18. So we're going to divide by root 3, so we get z is equal to 18 over root 3. We're going to rationalize that. So we get 18 times root 3 over 3, and 18 over 3 is going to reduce, and so we end up with 6 root 3. So that 6 root 3 is going to be the z value. So that's our z value. So now let's take a look here. So we need to find this value. So this value, remember, is going to be twice our z value. So we're going to get 12 root 3 there. And now the hypotenuse is going to be of a 45 degree angle. It's going to be x times the square root of 2. So we're going to set this equal to x root 2. We're going to divide by the square root of 2. And so we're left with, and then we have to rationalize it. So let's come over here real quick. So then we're going to end up with 12 root 3 times root 2 all over 2. These reduce, and I'm going to have 6, and then this is the square root of 3 times the square root of 2, which gives me the square root of 6. So I'm going to have 6 root 6 and 6 root 6 because x and y are the same. All right, take a moment to try and finish up 20 through 23. All right, so for number 20, you should have gotten 32 root 2 for x, y should have been 16 root 3, and then z would have been 16. 21, we should see 6, 6 root 3, 6 root 6. For 22, 14 root 3, 42, and 21 root 3. And lastly, for 23, we should have seen 10 root 3, 5 root 3, and 15. And that concludes the section.